Our group name is the Three Musketeers. It consisted of Charles Vaughn, Jacob Jacobs, and Hal Fang. And together we built a Rube Goldberg machine. The engineering design cycle, or the engineering design process, is made up of 5 basic parts: ask, imagine, plan, create, and improve. Once you have approved your project, it is very beneficial to repeat the process over and over again until you get a perfect final finished product, which is what we had to do in our project. Here are the many different parts of the design cycle that correlated to our project.
First, we must ask what the problem is. Our problem was to build a Rube Goldberg machine that flips a quarter in a cup. Our constraints were it must include 3 out of Rube Goldberg's 5 simple machines, had to be 2 by 3 feet, and no more than $40 could be spent on our project. Next, we had to imagine and brainstorm our ideas. We all came to the library and discussed multiple ideas and how we could use different simple machines to get a quarter into a cup in a cool and very interesting way. We chose our best idea and the best idea we could come up with to form a plan. Next, we planned and drew a diagram. We drew up a diagram and tweaked it to our liking. Once we had successfully drawn our diagram that we liked, we gathered our needed materials from Lowe's Hardware. These materials included plywood, 3 cups, 2 golf balls, 2 pulleys, 8 feet of rope, wood glue, spray paint, a door hinge, and the scrap wood that we found in the wood shop. Finally, we had to create. We had to follow a plan. We met multiple times in the wood shop to build our finished product so that it gave us plenty of time for testing. We tested the project as we built it, and then once it was finished, we tested it over 100 times for our suite mates and hall mates.
Number 4, create. We built the machine in the wood shop, and we met there many times in order to design and test it together. We tested it every step during the process. That's why we can get almost 100% success rate when the machine works. Then, procedure. We cut the whole plywood into correct sizes. They are the 3 walls of the machine. Then we picked up many scrap wood to build the supports of the inclined planes of the ball. Then we fixed the pulleys on the balls using strings and cups, and we fixed the final cup and the lever. At last, we painted it into black and red. We tested and measured many times between every steps. This picture is when we built the inclined planes and the supports. Almost all of the scrap wood we used was fastened by nails. The next picture is when we almost completed the project and tested it. The last picture is after we painted it into black and red. We also painted our name on the walls. Number 5, improve. To make needed changes. In the process we built the machine, we continuously made many changes because we found many plans that didn't work, and we changed our plans timely. So what we wanted was just the tennis ball can go wherever we want. So it's not difficult if we add dam boards on the ways. The most difficult thing was to make it run into the cups. So we changed the cup's position and put it in a correct angle. After we finish the improvements, we can make our project run perfect.
Our group managed fairly well at the Fed competition. Our machine worked for the judges, even though it didn't work for Dr. Sharma when she came right after the judges left. And we tied for 6th place, or last depending on how you look at it, since over half of the groups tied for last. And overall, we received a score of 94 out of 100. If our group ever had to do this project again, we would give our future selves 2 basic tips. First of all, we should have went above and beyond what we were required. We shouldn't have just kept to the bare minimums, and that's the reason we didn't place in the competition. Our machine met all the requirements, it was functional, it never broke, but other groups went above and beyond and did a lot more than they were required, and that's why they beat us in the competition. Our second advice to ourselves would be to be creative. We use simple tools, rope, pulleys, wood, balls, your simple Rube Goldberg devices. But other groups use really creative things like toy cars. Some of them use cans, some of them use water. And we weren't as creative as they were. And their creativity is what put them ahead of us in the competition. If we were to give advice to freshmen next year that were doing this project, first of all, it would be to start early. A lot of groups, including ourselves, were rushed for time towards the end, trying to get everything done, make those last minute adjustments, and keep testing the project to make sure that everything would be perfect on design day. And also, we would tell them not to underestimate how much time and effort you'll have to put into your project. Our group went in thinking that Rube Goldberg wouldn't take any time at all, but in actuality, it takes a lot of time to design rather than a lot of time to put together, which is what we didn't anticipate.